Hello and welcome to this new part in our mini-series on how to use language models together with graph databases like Neo4j. In my previous video, I covered how we can use language models to extract entities and relationships from unstructured text documents and JSON, and then run some Python to automatically create a graph database from those entities and relationships. Now this video is the obvious sequel to that one, where we are now going to build a chat interface to that graph database, where we will again use a language model to ask natural language questions, then convert those into Cypher queries, run those queries against the Neo4j database, and then finally answer that original question by using the results from the database. And if you're new here, I'm Johannes. I'm a freelance data engineer and data architect. And on this channel, I create content on how to create advanced language model applications from that data perspective. And so if you haven't seen this previous video that I just mentioned, I highly recommend you check it out. Otherwise, if you have seen it already, then let's jump into this one. I hope you enjoy and find it useful. Okay, so let's get started. We are here in our familiar repository from the previous parts. Here's the notebook with all the code to generate the knowledge graph. Again, if you want to go through the deep dive on that, do watch the previous part. Now for the UI and the chat interaction, we're going to create a new file. And we'll be using Streamlit to build this simple demonstration application with a chat to our knowledge graph. So we'll be importing that. A few things actually. And then we'll start by defining some basics for the website. Some columns to have a page title, maybe some image. And we'll just put a Neo4j logo up there on top of the page. And then we'll have the user input elements. And then when the user does enter a question, then we are going to run some action. And now if you aren't familiar with Streamlit, we're just going to run this now, which we can simply do by running the command Streamlit run and then the path to the file. And then this way we can just very easily run this kind of a simple web application locally and do some testing and play around with it and then see the changes in real time. And so now this starter application looks like this. So we're going to start adding functionality on top of this basic frame. The image is a little small, but we'll fix that. We'll make it a little more spacious. For starters, we're going to set the page configuration to use the wide layout option. And then again, if we refresh this, we can immediately see the effect, like so. Now for the actual functionality, first of all, when we get a new question from the user, we're going to add that to a session state object. And what this is going to do is just maintain a history of the entire chat, the conversation throughout our whole session. And additionally, when building these kinds of Streamlit applications, it's a good practice to initialize these kinds of session state variables, which just means that at the beginning of the application, we initialize it as an empty list, just to make sure that these variables are always defined when we start to refer to them. And then next up, we're going to start a timer so we can see how long it takes to handle each request. And this is going to require another import from the timeIt library. And now we can start looking at the actual main function that we're going to use to query the graph. And we're going to start defining it here, mainly from LangChain. These are going to be really useful, as you're going to see in a second, because LangChain, in fact, has this class for doing exactly what we're about to do, which is to translate natural language into Cypher searches, and then also translate the results back into natural language. So this is going to make our life a lot easier. Nice. So first of all, we're going to define our language model wrapper using the Azure Chat OpenAI wrapper from LangChain. And because we're using OpenAI's models here running on Azure, here we are setting our endpoints and our credentials for accessing the API. And the OpenAI API type, that's going to be Azure, as opposed to just using the OpenAI API directly. And temperature 0 to reduce the amount of randomness in the responses. And then also the deployment name, which is going to specify exactly what model we are going to use. And in this case, we are going to use GPT-4. Originally, I tried to use 3.5, like we did when creating the knowledge graph. But I found that for generating Cypher, GPT-4 really performs a lot better. 3.5 does make quite a lot of mistakes in the syntax. So this is going to be very, very useful. Also going to add some missing imports to get the environment variables, which I have stored here in the .env file. I go into more detail in the previous video on where do you actually get all the credentials and how do you store them in the .env file. I'm not going to go through it again in this video, but if you do want a deeper look at how you can get started using Neo4j, how you can create a database in just a few moments, and then how you can set up all the credentials, both for Neo4j as well as for using OpenAI on Azure. I cover all that in my previous video, the one I posted before this, so you can go check that out. And this we can actually copy from our notebook that we used previously. These are going to be exactly the same. We get the endpoints, username, and then the password. And now we can start defining the function. So first of all, we're going to define the Neo4j graph object here that we import. And it's going to take 3 arguments. It's going to take the URL, the username, and then the password. And this is an easy way for us to interact with Neo4j through LangChain. Similarly, we're going to define the graph Cypher Q&A chain. And this is going to take a couple more parameters. It's going to take the language model, first of all, that we want to use for the conversation. It's going to take the graph that we just defined here, setting verbose to true, and this is going to print out all the intermediary steps that the chain is going to do during the conversation. And then we're also going to want to return those intermediate steps in the final result. That's going to be useful for us because we want to display those in the UI. So that's things like the generated cipher, the results that we get from the database, instead of just the final answer. And then finally, we're just going to have a prompt for generating the cipher. So there's going to be some custom instructions there that are going to be necessary. And that's going to be it. We're going to define this prompt in a second. But otherwise, we're going to get the results by running the chain with the user question, with the user inputs. And then the return, like I said, it's going to contain everything we need to show in the UI. So we're just going to return all of that. And that's basically the function. Now, where there is a lot of interesting stuff here is in this prompt. So we're going to look at that next. So we're going to define that here. And I'm just going to paste this here and then explain in more detail. So the first line, pretty standard. You are an expert Neo4j Cypher translator, converting English to Cypher based on the schema provided. And then we're also going to define some extra instructions here to address some of the mistakes and confusion that I've noticed the language model does when generating Cypher. So the first one, we specify which version of Neo4j to use, 5 being the latest. So we want to use that because, of course, over time, syntaxes can change as with any language. So we want to make sure that we don't mix different versions that aren't compatible. And secondly, we're going to mention some very specific keywords not to use because these don't exist in Cypher, but they exist in other database languages like SQL. And I've noticed that sometimes this causes confusion with the language models. So when we specify not to use these words, then that's going to help, I noticed, to reduce this kind of hallucination quite reliably. And these kinds of instructions can sometimes be a bit of a hit and miss. Sometimes the language model goes and does the mistake anyway. But here I found that this is actually very effective for getting rid of this issue. Next up, another failure mode I've noticed is that sometimes the language model refers in the Cypher to node types and relationship types that don't actually exist in our database. So for example, in our graph, we have the has client relationship that's defined between the projects and the clients. But sometimes the language model would instead reverse the direction and think that there is a has project relationship from the client to the project. Now this direction of the relationship doesn't have any impact on which direction we can search. Regardless of how you define the relationship and its direction, you can still search either way. But the name still has to be what we have defined, what's in the schema, as well as the arrow in the syntax indicating the direction. So this needs to be correct. And so that's why we have the instruction number 3 to try and reduce this issue. Now number 4, here we define that we want to do case insensitive and fuzzy search for anything that we are looking for. And so what this basically means is instead of looking for exact matches, we are always wanting to use keywords like contains. And this is super important because although the language model here has information of the schema of the graph, it doesn't know exactly what each field contains in all the nodes. So if it's going to try and look for exact matches like client ID equals something, it's just going to try and guess exactly what the fields are. And this is just going to miss most of the time. So we define that here. And for the projects, we actually want to use 2 different fields. We want to look for things in the summary field, and we want to look for things in the name field. And we want to get the results if either of these fields contains the thing we are searching for, instead of having an AND keyword here. So this is all just to make the searches more flexible, so then we are more likely to get some results for our search. Now these 2 last ones are basically just repeating some of these earlier instructions. Never use relationships that are not in this given, and never use relationships that are not in the given schema. That's basically the same as number 3 in different words. And then number 6 just reiterates how to search for projects. Now this is admittedly pretty hacky, but sometimes when you repeat these kinds of instructions more than once in the prompt, then it makes it more likely that the language model is actually going to follow the instructions, because like I said, it's not quite as clear as just giving instructions and then being able to trust that the language model is always going to follow those instructions. So this kind of repetition can also be useful sometimes. And then here we have a placeholder for the schema of the graph that we're going to pass to this template. And then finally, we're just going to do some few shot prompting, which just means that we are giving some example questions and answers to help orient the model. And then finally, another placeholder where we are going to pass the actual user question. So that's the prompt. And so you might get the impression already from the size of the prompt and all the elaborate specific instructions we need to give that generating Cypher is something that these language models, even the top of the line GPT-4, really aren't the best at, and they do still make mistakes. Even with an elaborate prompt like this, we can only do so much, and so this wouldn't fly in a production setting, unfortunately. But before you fall into despair, there is a solution, which is fine-tuning. And you probably heard of fine-tuning, at least in some capacity. But what fine-tuning is, basically, it's the process of training a base model further, essentially making it perform better in some specialized task that your fine-tuning dataset is focused on. And so in this case, our special case would be to generate Cypher. And the good news is that this has already been done and shared by Thomas Bratanik, who's a researcher at Neo4j. And he's been very active in this space, posting a lot of great articles like this one, already way before I was talking about this stuff. This one is back in April last year. And so what he's done here is he's fine-tuned an open source language model to perform better in generating Cypher statements. And in this article, which I'm going to share a link to, he walks you through the process in great detail. But the bottom line for us here is his conclusion in the end, which is that he feels confident that you could fine-tune a model to generate Cypher good enough for a production setting. And so this is what we want to know if we are dreaming of making something like this in production in the near future. And so I feel very confident that with the combination of fine-tuning as well as near future advances in the capabilities of the base models themselves in the next year or 2 years, I think this is certainly not going to be an issue. But for now, because fine-tuning is a more involved process, this kind of a prompt engineering is going to allow you to just get started a little faster and simpler, experimenting with this kind of stuff. So let's carry on with our example here. So with this template defined, we can now define the prompt itself, which we're going to do with the prompt template class from LangChain. And this way, or this extra step of defining prompts might seem a little confusing, but the bottom line is just that LangChain and these chain objects defined by LangChain expect these kinds of objects, prompt templates, to be passed here. So that's the reason why it's done this way. And with that, we are ready to send some results from this function back to our UI. And then we're going to pass those results a little. Like I said, it's going to contain a bunch of stuff that we are interested in, because this result here is a dictionary. And among other things, it's going to contain a key with intermediate steps. And this is further going to contain our Cypher query that we can access like so. And then additionally, it's going to contain our database results, which we can access here. And then finally, of course, it's also going to contain our final answer under this kind of a key. And so with the final answer, just like with the user messages, we are also going to save these, all the responses, into the session state. I will just call it system messages. And then we're going to append the answer every time we get a new answer. And also for this session variable, we're going to initialize it as an empty list. And now that we are maintaining and building this history of the chat, the conversation, then we can now display that conversation. And so if there are messages in the history, we're going to loop through those messages, and we're going to do it in a reverse order. That's what these -1s are for. So we start from the newest message, display that first, all the way to the oldest message in the history. And this is actually a system message. And then between these system messages, we're going to show the user's input. And that should do it. And let's see how that looks like in our application now. Oh, we have a little import error here. This one, Neo4j graph. Oh yeah, this should be a lowercase j, and then this one as well. Now let's try that again. Refresh, and there we go. And now let's try a simple question. Great, except both of these are listed as the user sending these messages, so we made a mistake somewhere, but we'll fix that. Oh yeah, this should be the key. So what we're also going to do here is we're going to create 3 columns in the UI. And then this way we can have the chat history in the first column. And then in the second column, we're going to have the Cypher query that was last generated. And then finally in the third column, we're going to have the last retrieved database results. And then that's going to give us some nice visibility behind the scenes, what's actually being done under each query, like so. Beautiful. Now, the issue that some people do find with LangChain is that although it can help you get started very fast, when you want to do some customization to how the components work, that can be a little tricky. Their documentation isn't always up to date, and it is a very fast-moving library. So it can be hard to understand what exactly this component here is doing behind the scenes. For example, if we wanted here to customize how the final answer is formatted from the language model, how would we go about doing that? Because this prompt here, this is only used for generating the actual cipher, but then when we get the database results and we use that to create the final answer, then this prompt isn't used anymore in that step. So even if we added some instructions to this prompt, let's say give your answer in bullet points or a table or German, then it wouldn't matter to the final response. There are 2 different steps and they use different prompts. So if we go to the LangChain documentation for this component, we can actually find out that there is another argument. Aside from the Cypher prompt, there's also a Q&A prompt that we can pass to this class. And then there is no explanation exactly what this argument does in the class, but we can assume that this probably does what we want. So what we can try and do is we can pass a prompt like this, and then just do something similar as with the Cypher prompt, create another prompt template with something simple, give your answer in bullet points, and then we don't define any input variables. Let's see how this works. Going back to our UI. And now we run into issues. We can see that the Cypher works fine. We get the correct response from the database, but for some reason, this information doesn't get passed on to the language model, and therefore we get this kind of an answer. And the documentation doesn't really help us here because, like I said, there's no information about this Q&A prompt whatsoever. And then this is the point where especially a lot of beginner people run into a frustration. They don't really have anything to go on. And what they will often then do is try and Google, find out if somebody else has run into the same issue, if somebody else has done the same thing. And sometimes you just can't find an actual example of how this is used. But what's also useful to understand is that we can actually find all of the components and all of the classes in LangChain by going to the LangChain GitHub repository. And this might seem obvious to some, but again, for more beginner people who are just used to importing a library and using some functions and not really having any additional questions beyond that, it might not be so clear. And so I wanted to use this opportunity to talk about this for a little bit and show how you can navigate these kinds of library repos and find the components that you want to look into in more detail. And so here we have the libraries under the libs directory. And they also, as well as the main LangChain library, they have the experimental library for more still in development features. What we are looking for is in the LangChain main library. And where exactly we find the component here, we can see that by looking at our import. In this case, this is the component we are interested in. So it's langchain.chains. So it's the submodule chains in the main LangChain module. So in the repo, if we go to LangChain, here we see the chains module. And then here in the graph Q&A, we can find what we are looking for. So under the Cypher PY, we can find the Q&A chain. And then looking for the specifications for the Q&A prompt, we can find that under this class. And this part here is going to tell us that the chain is going to use the Q&A prompt that the user passes if they pass it. But if they don't, then there's a default prompt that's used. And so where exactly we find this one, then we can see that this is also imported from yet another LangChain library or submodule. So we're going to have to do a bit more digging still, going under chains and graph Q&A and prompts. So it's in this same folder in the prompts. And then somewhere here, we can find the default Q&A prompt that's being used. And here it is. It's pretty generic for the most part. It's a good, decent prompt. But most of all, what it's going to tell us is going to tell us the expected input variables that we should pass. So it's expecting context, which is the results we get from the database, and then the question from the user. So with this information, we are now in a better place to then define our own custom Q&A prompt, because we can just copy this into our own code, and then we can make any necessary adjustments here. We'll keep the expected input variables that are going to make sure that our database results and the user question will get passed on to also the Q&A or the final answer step. And then we can also still make any additions or changes to this prompt here. For example, we can add here that the final answer should always be in Spanish. And now, if we try it again, then we get the result we want. Now, I hope that little detour to LangChain's inner world was useful. But I think in the context of working in this kind of a fast-moving and cutting-edge space, it's good to have this understanding, because you can often be working with these kinds of niche libraries where the documentation isn't always perfect and they are changing a lot. It's good to have this understanding that all the code typically is going to be available in a place like GitHub, and you can actually navigate it, find all the classes, all the functions in full detail, see what they do, and then you are in a better place to understand them and then make any adjustments as you need for your specific use case. Okay, so just jumping back to our code for some final touches. We are basically finished here, but there's a few more things I want to add. First of all, we are going to add some exception handling in case we get some errors with the Cypher, as sometimes happens. So we're just going to have that here. Put this in a try block. Write out the exception. And then we're gonna put this under a spinner element, which is just, you'll see in a second, it's just this visual element in Streamlit to indicate that something is being done. And so we're gonna see that visual element while it takes us a while to process all of this, call the language model, call Neo4j, etc. And then finally, we're also gonna use the timer we set here to show how long each question takes to answer. And then finally, we're going to take away this Spanish line, and we're just going to ask for the answer to be easily readable and structured. And let's see what that's going to give us. And then I'm just going to ask one more question. And this is the spinner element that I mentioned, because this default running indicator up here, it's very easy to miss. And it's nice to give users some indication that something is being done. And here we go. Now we are getting the answer in a slightly more structured way. The paragraphs are being separated nicely with our additional prompt. And that's going to wrap up this tutorial on how to create a chat interface to a graph database.